I hope all of us have learned the basic concepts behind dynamic programming, how it is used, when it is used, and we have also done many questions based on that, right? So now what we are going to do is we are going to do some more problems on that, definitely, but let us first do a warm-up problem before we move into some well-known and complicated problems. Okay, so I'm going to pose a very simple problem to you based on DP, and then let us say how we are going to do it. Okay, so you have been given a set, and I think all of you know what a set is, right? It contains unique elements. Okay, so this is the set which is given to me, which contains all the unique elements. Now the question is that I want to find the sum of product of all the subsets. This is the question. I want to find the sum of product of all the subsets. So just to make it clear again, if there is a set, of course it will have multiple sets, multiple subsets basically. Of course it will have multiple subsets. Now for each subset, you can take the continuous product of all the elements present in that. Okay, once you have done that, then you sum those up. So that is what is the requirement over here. Just create multiple subsets, from each subset get that product and then sum up those products which you have got. So is the question clear to all? Just type in yes if you understood the problem. Okay, cool. So let us take a very quick example. Let's say I have got A comma B. Okay, this is my set and I have got A comma B in it. Can you tell me what will be the answer for this case? So just type in the answer that you feel should be corresponding to the requirement that you see on the board. Okay, so I see that many of you are typing the answers. Cool, so all of those are correct. So tell me one thing, how many subsets will it have? This contains two elements, so how many subsets will it have? So 4 subsets, right? Because for any element I have got two choices, either I can take it or not take it. And since there are n distinct elements and 2 distinct choice for each element, so by rule of product I can say I'll have 2 raised to power n different subsets. Okay, so first subset will be an empty one, second would be just A, just B, and then both A and B. If I take a look over here, the product of elements over here is 0 because there are no elements at all. The product of elements over here is A because just A is there. Here it is B. The product of elements here is AB. And if I sum them up, then what I am going to get is A plus B plus AB. This is what is the expected answer over here. Is everyone clear with the output, how the output is A plus B plus AB? Just type in yes if you are clear with the output. Okay, great. So this is what the intention of question is. Now think about some solution, and if it strikes your head, just let me know. Okay. So come on guys, this was a warm-up problem, so I think you guys should be able to talk at least something about it. Anyone who has some kind of approach in his head? So one of you is saying that we can create all the subsets and store their products, and yeah, that would be a brute force approach. So I think brute force approach is very simple, that you can simply generate all the subsets of a set, and once you have generated them, then you can take the product of elements in them and then you can add those up. How many of you can implement this approach? Can all of you implement it? Yeah, cool. So this should be easy enough. Can somebody tell me the time complexity of this brute force approach? So first thing is evident that the code which I will write to generate all the subsets, it will take almost 2 raised to power n time, right? Because these many subsets will be there. And now whenever I have generated a particular subset, then I need to product all the elements which are present in that. So at max there can be n elements. So taking product of all the elements of a particular subset can take me at max order n time. So I can say this thing will be order of, to be more exact, order of 2 raised to power n into n. This will be my overall time complexity. But if let's say your n is huge, if your n is of the order of 10 raised to power 6, this thing is going to time out, right? So I have to think of something better over here. According to me, we can make some pattern in it. Okay, so one of you is talking about creating a pattern in it. Very good. I think that is a great observation. Anyone else who is able to see any kind of pattern over here? Okay, so let me help you out. Let us say earlier I just had a comma b in my set, and now I am saying that hey, let me add c also. So I have a, b and c in my set now. Okay, cool. So can you tell me, okay, so just read me what few of you are writing. So one of you is saying single elements and their product. Okay, does not make a lot of sense actually. By taking two variables, okay, yeah, so the pattern that you are talking about is right, but how will you, how will you decode that pattern, and how will you write a program corresponding to it? So you have to be a bit more clear. Anyways, tell me how many subsets will be there for this particular set? Yeah, it will be 8, right? So one of you have written 2 raised to power n minus 1, which is wrong. It is 2 raised to power n always, because you also take into consideration the empty subset, right? Now it is a different story that the contribution of this is 0, but this is also a subset, right? Cool. So let me just write down all the subsets of this. So I have are these the 8 subsets? Can I say that? Yes. So what one of you have written, that first store products of single element, then use those values, find the product of two sized subsets. Yeah, that makes perfect sense. That is the right solution for this. Guys, can you just acknowledge if you agree whether or not these 8 are the 8 subsets? Yes or no? Yes, they are, right? Okay, cool. So if you take a look over here, how many subsets are there in this much of collection? How many subsets are there which contain C in them? How many subsets contain C in them? There are 4 of them, right? Okay, cool. Now can you observe something, that hey, this thing is basically this thing only? Can I say that? Yes or no? I can say that, right? Because all the subsets of this will also contain all the subsets of this, because this thing got created by merely adding one new element to a comma b, right? And now if you closely look at this, then this is nothing but each of these appended by C. If I append C over here, I'll get this. If I append C over here, I'll get this. If I append C over here, I'll get this. And for this, I'll get this. How many of you are able to make sense out of it? Just type in yes. Right? So this is the most important observation over here. What is the most important observation? Out of all the 8 subsets that I have, I can talk about 2 categories, category 1 and category 2. Category 1 is that category which is without C, and category 2 is that category which is with C. Okay, and the quantity of elements over here will be same as the quantity of elements over here, because the moment a new element comes, previous subsets will be retained, but all of them will give birth to one new subset, which will be nothing but that subset appended with C. And because they are distinct, so their children would also be distinct. And also all of the subsets over here will contain C and all of the subsets here will not contain C. So it can never happen that there is something over here which is also over here. So these two are mutually exclusive. Okay. So this way I can say that, hey, if for, let's say, I had A0, A1, A2, I had these many elements, and number of subsets that I could create is S. If number of subsets that I could create is S, now let's say A3 comes. Can you tell me what will now be the total number of subsets? If a new element comes like A3, what will now be the total number of subsets? Yes, it will simply be 2 into S, right? Guys, are all of you able to understand that? Yes or no? Okay, I think this is simple to get, right? Because all of these subsets here were retained, they just give birth to few more. Okay, how many more? Exactly as the number of elements over here, right? The same thing will happen here also, right? If you have, let's say, S subsets which you create out of these many elements, those S subsets will still be a part of all the subsets of this much, right? But now there will be a new class of subsets which will be generated by appending A3 to each of the elements in this. Now does that make sense? Yes or no? Before I move ahead, can you type that? This is easy, isn't it, guys? Do you feel this observation is a hard observation or this is an easy observation? What do you feel? I personally believe this is a very easy observation, right? So things become very easy then. So tell me one thing, for this particular case my answer was this. Okay, now can you simply tell me the contribution of category 2 if you know this thing? What will be the contribution of category 2 if you already know this thing? Is it easy to determine? Yes or no? Is it easy to determine? Yes or no? Yes, that is right. So I can say that, hey, the moment a new element comes, the answer over here will be contribution of category 1 plus contribution of category 2. And contribution of category 2 will be nothing. If I know this answer, then all of these have got appended with C in them. So like this A got appended with C, this B got appended with C, this AB got appended with C. Okay, so basically the contribution of that will be C multiplied by this previous thing, which is A plus B plus AB. But one more thing, this is empty and a C came over here. Okay, so the contribution of this has to also be counted. So it will be C times of, which is your new element, times of, let me call it previous sum plus 1. So this will be the contribution of this category 2. Is that clear to all? Yes or no? Right? And now this is the contribution of category 2. Okay, and category 1 I already know. Category 1 is nothing but this previous sum itself. Okay, so I can say that, hey, if a new element C comes, then my current sum will be nothing but new element multiplied by current sum plus 1. And what is this? This is my category 2 plus this, let us call it previous sum. Okay, plus previous sum. Okay, why? Because this previous sum is this category 1, which will continue to be a part of this entire thing. So I think this is the way in which you can easily solve this. If you know the previous sum for, let's say, first 3 elements, then you can figure out the answer for first 4 elements also in a very easy manner. Is that clear to all? Just type in yes or no. Okay, cool. So this is the way in which I can very easily solve this problem. So if you have, let's say, 1, 2 and 3, okay, then always to start with, see, in order to find the answer for this much, you need to know the answer for this much, and in order to know the answer for this much, you need to know the answer for this much. Okay, so you would always want to initialize your answer for this much, which is just one element, which is just a of 0. So can you tell me that if I just consider this much of the array, what will be the solution? What will be the solution if I just consider this much of array? It will just be 1, right? Because if I just consider this much part, there are only 2 subsets that can be generated, which is this and this, which does not contain anything. So 1 plus 0 will be 1. So to start with, I can initialize my answer as a of 0, which in this case will be 1. Okay. Now the moment you include one more element, so now your intention is to figure out that, hey, if this much is my array, okay, then how many subsets can I generate, and what will be the sum of product of those. Okay, so for that, what I can do is, if you take a close look over here, this 2 can get appended with this and can also get appended over here. Okay, and this thing will continue to exist. Okay, so for this, the answers will be 1, 0 and empty, 1 appended with 2 and 2 appended in empty. So for this category 2, I told you, for this category 2, I have to do new element multiplied by previous answer, which was 1 plus 1. Why this plus 1 I am doing? This is for that empty thing, right? And plus again the previous sum. The previous sum was 1. So this is 4 plus 1, which is 5. And here, if you take, this will be 1, this will be 0, this will be 2, and this will be 2. This thing is 5. Now again, the moment you include a new element, is everything clear till here? Just type in yes or no if you are getting this thing, right? So now similarly, the moment you include a new element, which is this, so what would happen? Again, your current sum will be, so basically you always write your answer as, so currently your answer is equal to 5. New element that has come is 3, so it will be 3 multiplied by previous answer, because this 3 would get concatenated with this thing, as well as this thing, and also it will get concatenated over here. So 3 multiplied by 5, which was sum of this, and this, plus 1, which is for empty set, and plus the old contribution, which was 5. Okay, so this is 6 into 3 is 18, plus 5 is 23, and that would be your answer actually, right? Because if you include a 3 also, then you will get 1 3, just 3, 1 2 3 and 2 3. So here it is 3, here it is 3, here it is 6, and here it is 6. 6 6 12 plus 6 18, and 18 plus previous answer is 23, and that is exactly what my answer is. Okay, how many of you can code this solution? Just type in yes. Okay, what do you believe will be the time complexity of this? How much time? So you are incrementing your span by 1 unit each time, and to figure out the answer, you are just doing constant number of operations. So it will simply be order of n, right? Now this is a very classical case where I can figure out the answer of a bigger problem if I know answer of a smaller problem. And the same thing was true here also. I could solve this because I had solved this. So you can solve something bigger if you have already solved something smaller. So that is a big property of dynamic programming, and this is also something which is referred to as optimal substructure. Optimal substructure means nothing but only this much, that if I have been given a very large problem, and if I focus all my attention to solve that large problem, it can get tough for me. So why not solve the smallest problem first, and then something which is larger than that, then something which is larger than that. So that way you can very easily get this done. So I'll quickly write the code for this. So you can always initialize your answer to 0, and then you can simply iterate from 0 to n minus 1. Okay. So you can also initialize your answer to a of 0 and then iterate from 1 to n minus 1. That is also perfect, but you can do this also, because initially you consider that you do not have any elements with you, right? When you do not have any elements with you, you just have an empty set and the contribution of that is 0. So here what you will do is you will do answer equals to the new element to come is a of I, that multiplied by previous answer plus 1 and plus the previous value of answer. Just this much is the code. Yeah, so this was a warm-up problem. Just type in yes, those of you who understood the code clearly. Got it? Okay. Another important thing that I want to illustrate over here is you guys have in the previous classes you have seen the various styles of writing DP code, various styles of approaching a problem. So there were two popular styles. Can somebody name those out for me? What were the two popular styles for solving a DP problem? So it was top bottom and bottom top. Yes or no? Yes, top bottom and bottom top. And top bottom, what was top bottom? It was something which was recursion plus memoization. Why? Because while performing recursion, there were overlapping subproblems, and instead of solving something which I have already solved again, I used to store its value in memoized data structure. Could be a 2D array, 1D array, depending on whatever is your state, and then update it. Is this a top-bottom approach or is this a bottom-top approach? So this clearly is a bottom-top approach, which is also called as tabulation, right? I hope everyone is understanding that, yes or no? Right? So this is clearly a bottom-top approach. There is no recursion here. You fill up your answer from from 0 to n minus 1 or from n minus 1 to 0. That's totally up to you. Okay. Cool. So see, one way to solve this problem could also have been that I create a DP array, DPN, okay, and I define my DP of I in this way. I define my DP of I in this way that, hey, if I consider the portion of array from 0 to I, then what will be the answer over here? So if you store this DPI array, okay, then from DPI you can always create your DP of I plus 1, and then from DP of I plus 1 you can create your DP of I plus 2. Are you getting the point that I'm trying to say? Yes or no? Yeah. So this the value of answer over here is nothing but DPI, okay, and this previous answer over here is nothing but DPI minus 1, okay. So this is the point over here, okay. Did you get it now? Yes or no? So DP of I minus 1 is nothing but answer for the previous problem, which was from 0 to I minus 1, and DPI is the answer for current problem, which is from 0 to I. Did you get it now? Yes or no? Right? Yeah. But if you try to do this, I would say the extra space would be order n. Your time complexity will be the same, but extra space will be order n. Can I say that? Yes or no? Because you are unnecessarily creating that DP array of size n. Now tell me one thing, is that DP array required over here? That is not required over here. Why? Because in order to find the solution from here to here, I just need the solution from here to here. What I mean by that is, let me give you a generic example. If I have to tell the answer for this much of part, then I just need to know the answer for this much part. Yes or no? I do not need to know the answer for this much part or this much part or this much part, right? So why store the previous to previous or previous to previous to previous answers? Just store the previous answer and just update it to your current answer. That's it. That's how your job would be done. Does that make sense to all? Yes or no? Okay, so there is a question, sir, can we also do this problem, sum of the sums of all subsets? Yes, you can try that out. So one of you have raised a question, what if the question was to find sum of sums of all subsets? So that is even easier. That is a much easier problem than this. So just think about it, not right now, but later on you can think about it. That's also a good problem, but it's quite easy. You can do it without, having to apply DP as well. So an important thing to understand over here is that bottom top approach helps me save my space. Why? Because I always know that, hey, if let's say these are the cases where my solution just depends upon the previous problem, and if I am solving the problems in a sequential manner from 0 to n-1, then I can just have a variable and update that and find the solution to my next problem. So in certain cases, not everywhere, but in certain cases, it is often seen that bottom top approach helps you save the extra space. Okay, so you need to know that what are the pros and cons of using which approach under which kind of circumstances. Is that clear to all? Just type in yes or no. Everyone got that? Okay, let's move on. Okay, now we will go on to some very popular problems of DP. Okay, and we'll also learn that how to apply them at certain places. So let me tell you the problem statement. So the problem says that I have been given two strings. Okay, two strings S1 and S2 of size m and n. Okay, let's say this one is A, B, C, D, G and H, and let's say the second one is A, E, D, F, H and R. Okay, does everyone know what is the meaning of a subsequence? Do you understand the difference between subsequence and a substring? What is the difference? The difference is that if I give you a string like A, B, C, D, E, then a substring can be this, it can be this, it can also be this. So a substring has to be contiguous. Okay, if it was a substring, then it has to be contiguous. Okay, but subsequence needs not be contiguous. In subsequence, you can think of subsequence just like this, that hey, you take the original string and then you let go of certain characters, and then whatever remains, that you consider. But while considering them, you are very particular about their order. So you do not want to change their order. So you simply let go of certain elements, and then whatever remains, that is a subsequence. So AC is a subsequence of this. ADE is also a subsequence of this. Is DE also a subsequence of this? Can I say that? Is DE a subsequence of this ABCDE? Yes or no? It is, right? It very much is. Okay. And how about something like ADC. Is ADC also a subsequence of this? It is not. Why? Because I can definitely get A, C and D if I drop B and E, but that will be ACD, that will not be ADC. So this is not a subsequence. So I hope everyone is clear with the meaning of subsequence. Yes or no? Yes, order cannot be changed. That is the most important thing. ACD will be correct. Okay. So now that you understood what is subsequence, the question says that I want to find the longest common subsequence. Longest common subsequence of S1 and S2. So if you talk about the two strings S1 and S2, this is my S1 and this is my S2, they have got multiple common subsequences. If you forget about this word longest, they have got multiple common subsequences. Yes or no? Right? Can you type down certain common subsequences which both of them have got? Yes, correct. So one common subsequence that I can clearly see is just A, because A is present here also and here also. Another one that I can clearly see is AH, because I have AH here also and I have AH here also. Okay. Another one that I can see is I think DH, because DH is here also and it is here also. So they are different common subsequences, but out of all the common subsequences, I need to know the length of longest common subsequence. The length of this was 1, length of this was 2, length of this was also 2. Can you think of a subsequence which has a length which is greater than all these, and that is a common thing between S1 and S2? Can you think of something like that? Yes. So how many of you can see that is ADH? Just type in yes. Yes, that clearly is ADH. Okay. If I consider A, D, H, and if they happen to come in the same order over here, which they are, then I can say that hey, here ADH is the longest one. I'm not interested in typing ADH, I am just interested in its length. So my output here would be just 3. So is the question clear to everyone? Just type in yes or no. Okay, cool. Let us move on. So yeah, this is what my requirement. You have been given string 1, string 2 of length m and n, and you have to tell me the length of longest common subsequence of S1 and S2. So how many of you have some approach for solving this problem? You can just type in yes if you have some approach. Okay, so I see that 2 of you are saying yes. Okay, let us understand. Okay, so what is the most important thing while trying to solve a DP problem? So you start with a big problem. So the big problem is to find the LCS of this and this. Okay, now solving this thing is tough for me to do because both are having bigger lengths, m and n respectively, right? So instead of solving this bigger problem directly, can I first try to solve smaller problems, and once I have solutions to those, then I can in fact very easily solve the actual larger problem. So again, there are approaches here. You can go bottom top, you can go top bottom also. Top bottom is like using recursion, and because in recursion first the problems that you call, which are smaller problems, they get solved, and once they get solved, then you solve the actual larger problem also. Okay, so I think you can considering the fact that in previous classes you have done certain questions where we used recursion and memoization, so you can use the same thing over here. Think if that can be useful. Okay, that is the first hint that I wish to give. Second hint that I wish to give is, are you aware of the states? How many of you are aware of the state of a DP problem? Do you understand what does this mean? Yes or no? You can type yes or no if you understand what is the meaning of state of a problem. Okay, so this is a very, very simple concept. State means a number of variables that uniquely identify a DP problem. Number of variables that uniquely identify a DP problem. So if you take a look at your previous problem where I told you that I can use a DP array like this, DP of I. Which kind of state did it have? How many states did it have over there? Did I have one state? Did I have two states? How many? So I just had one state. Okay, so that was one state DP, because DP of I is clearly different from DP of J or DP of K. DP of I simply means that if I consider the portion from 0 to I, what will be my solution? DP of J means if I consider the portion from 0 to J, what will be my solution? And this means if I consider the portion from 0 to K, what will be my solution? Okay, these are the meanings of DPI, DPJ and DPK. Okay, so this was one state DP. But sometimes it can happen that the number of states that you need to solve a particular problem is more. It is 2 or it is 3 depending on the problem. Okay, so I have told you this thing before because I'll be using it, I'll be utilizing it. So let us all try to understand things now. Let's say there is a string 1 and then there is a string 2. Okay, so let's say this is my string 1, its last character is A, this is my ith character, and this is my string 2. Let's say its last character is also A, this is my jth character. Okay, so let's say you are trying to find the longest common subsequence of string 1 and string 2. Okay, so how can I go about? Let's say we start from the last characters of both. So how many things can happen over here? If I consider str1 of I and str2 of j, how many things can happen? Either they can be equal or they can be unequal. Okay, if they are equal, can I say that, hey, whatever will be my answer, whatever will be my longest common subsequence, that will definitely have this A as its last character? Can I say that? Yes or no? Yes or no? Think. Right? I can say that, right? Okay, so one of you says no. And can you if you're saying no, can you justify why do you mean to say no? So now in the meantime I'll prove why I mean to say yes. So the thing is very simple. Let's say whatever is the answer, whatever is the longest common subsequence. So it could be something like, let's say there was a x over here, and then for this x there was a x over here, and then there was a y over here, for this there was a y over here. Okay, so this xy matches this xy. From that I can say that, hey, this xya matches this xya. So if this is the case, then this A will definitely be the last character of the overall LCS, which is your longest common subsequence. Does that make sense to everyone now? Yes or no? Is it clear? Yes or no? Is it not just a common sense? What do you feel? This in fact is, right? Okay. See, now certain times what can happen is, I am going to give you another case also so that things are much more clear. So let's say this is my string 1 and this terminates with A, and this is my string 2 and this terminates also with A. Okay, so certain times the cases can be like this, that there was a P over here somewhere and there was a Q over here somewhere. Okay, but coming in the proper order, that is Q is coming after P. okay, and then there was a P over here and Q over here and A over here, okay. So let's say your answer is PQA. So you are saying that, hey, this P is matching this P, this Q is matching this Q, and this A is matching this A. So here you are saying that, hey, this thing is not getting considered. I can say that, hey, it's just a matter of common sense, you can consider that. Why? Because instead of matching this A with this A, you can also match this A with this A, right? Did you get my point? How many of you got it? Let's say yes. Right? So that's the overall point. So the entire idea is that if, let's say, the last characters of the strings that you are considering, now I am specifically using the word you are considering because every time you will not consider the complete string. Sometimes you will consider partial strings also. I am calling this right away. So the point is, whenever you are considering the two strings, if the last characters of the two strings are matching, then whatever will be the LCS of those two strings which you have considered, its last character will definitely be that last character, okay. So if you understand this, is it not okay to say that if this is the case where my str1 and str2 have the same value of last character, I have made an approach that I can share my approach, okay. Cool. So somebody had an approach, let us hear from him. I think he is Dishant. So if there is a quality issue, that would be because of your internet connection, okay. So Dishant Vashishtha, I have unmuted you. You can share your approach. I think you have shared your approach over the chat, okay. So let me mute you back then. So one of you have shared an approach. Cool. So I think that is a well-known approach. My intention was to hear the logic behind that. Anyways, so if you take a look over here, if string I and string j are same, can I say that, hey, LCS I comma j. Now I need to define this thing. See, the most important thing with respect to DP is that how do you define your problem? The definition of problem is very, very important. So I'm going to define it in this way. LCS of I comma j means that, hey, if I consider my first string as str 0 to I, okay, so if I consider that portion of string 1 which is extending from 0 to I, and if I consider that portion of string 2 which is extending from 0 to j. So now I'm not focusing my attention on this original str1 or str2. I'm focusing my attention only on the portion of string 1 which is from 0 to I and the portion of string 2 which is from 0 to j. Okay, and if I have to find the LCS of these, can I say that if this situation has happened, then the LCS of I comma j can be written as 1 plus y1, because these two characters were same. So I am very sure that whatever will be the LCS, that will have one character in it, which is this A. 1 plus LCS of some other things. Can you tell me what should these two other things be? What should they be? So they should definitely denote strings of size which are smaller than these two sizes. So what should they be? Can you tell me that? So they should clearly be LCS I minus 1 comma j minus 1, right? Why LCS I minus 1 comma j minus 1? Because what does this mean? If you heard me well over here, you can understand this thing also. This thing means the longest common subsequence if I consider the portion of string 1 from 0 to I minus 1, and if I consider the portion of string 2 from 0 to j minus 1. Now you can see this thing clearly, that whatever is the LCS of this and this, like here in this case, what is the LCS of string 1 from 0 to I minus 1? I'm going to write it. What is the longest common subsequence for string 1 which is extending till here and string 2 which is extending till here? Can you tell me what is it? It is xy, right? And that it is not xya. You did not hear the problem well. It is xy, right? Others, are you able to get this? Yes or no? I think this is a very simple point. So is there a confusion here? Yes or no? Can you quickly type that so that I can move ahead, or I can reiterate? Confusion. Okay. Okay, what is the confusion over here? Do you understand the meaning of LCS IJ? I'm doing it again, I'll not do it again. Okay. So do you understand the meaning of LCS IJ? Can you guys quickly type in yes or no? Is LCS IJ meaning clear to all? Is the meaning of LCS IJ clear to all? Okay. Okay, so I think the meaning of LCS I minus 1 J minus 1 should also be clear, right? Because what is LCS I minus 1 J minus 1? This I minus 1 means that if I am considering the portion of string 1 which is from index 0 to I minus 1 and portion of string 2 which is from 0 to J minus 1, then what is my LCS? Did you get that? Yes or no? Is that clear now? Yeah. So if my string 1 is from here to here and my string 2 is from here to here, which is the case here, then what will be my longest common subsequence? So what is my longest common subsequence over here? Can I say that is XY? Can I say that is XY? It is, right? And that XY can be appended with A because A is present here as well as here. Okay? Does that make sense to everyone now? Yes or no? Right? So that is the reason I am saying that if string 1 I is equal to string 2 J, then LCS ending at I comma J is 1 plus this thing. Okay? Is that clear to all? Yes or no? Yes, it is the case where the last character is matching. Okay? That is the reason I have written this thing explicitly after this. If your last characters are matching, in that case LCS IJ will be 1 plus LCS I minus 1 J minus 1. Before I move ahead to the other case where there is no match, can you tell me if you got this case? Others, is everyone clear with this? Yes or no? Right? Okay, so we all agree that this makes sense. But what if the last characters are not matching? If the last characters are not matching, I'll have something like this where stri of this is not equals to stri of this. In that case, what will be my solution? In that case, let's say I have something like this. This is A and this is B. Okay? If this is A and this is B, can I say for guarantee, listen to my question, can I say for guarantee that hey, my LCS will neither have A nor have B in it? Is this the right statement to make? Yes or no? It is not the right statement to make, correct? It is not. Why it is not the right statement to make? Because what if I had something like XXBB and I had a XXB. So now this B is getting matched to this B. Okay, so it can happen that although these two characters are not equal in themselves, but this character matched some other character in this string which is B over here. And the same thing can happen at the level of A also. Yes or no? Yes or no? Can I say that? Right? So the same thing can happen at the level of A also. Where, what do I mean to say is, let's say this one ended at A and this one ended at B, and let's say I have X double A over here, and I have XA over here. So this is matching this, this is matching this, this is matching this. So although this is useless, but this is useful. So I cannot discard both of them. So discarding both of them does not make sense, right? So in that case, I can say that, hey, I have basically two choices, you know. My first choice is where if this is my string 1, which ended at A, and this is my string 2, which ended at B. Both of them did not match. Okay, so my first choice is that I let go of this character. If I let go of this character, I am considering this much of it, but I will retain this character. So the representation of this is LCS I comma j minus 1. That is, I want to know that, hey, what is the LCS if I consider string 1 from 0 to I and string 2 from 0 to j minus 1. Does that make sense to everyone? Yes or no? Right? Okay, and what about the other case? The other case can be where I would want to retain this B but let go of this A. So if I let go of this A, it will be like this, and if I retain that B, it will continue to be like this. So this particular thing is corresponding to LCS of I minus 1 comma j. Now, do you know that which out of these two will be longest? Do you know for sure whether this will have a longer sequence or this will have a longer sequence? Do you know that? You do not know. So when you do not know, what do? You need to make a call to both these functions, and whichever out of these two is returning you the maximum value, that will be the overall answer for LCS of ij. So this is the case, this is the logic where the last two characters are not matching. But if they are matching, then I mean what I had done before, that I would continue to do. Does this second case of no match make sense to everyone? Yes or no? Others, right? Okay, cool. So technically what am I doing? So I'm going to write the things down over here. So if I have to find LCS ij, guys, unless you are not completely clear with the definition of this, please do not move ahead. Here the definition is very important. The definition is that my string 1 is from 0 to I and string 2 is from 0 to j. Okay, and then I am just interested in their LCS. I do not care about the world. Okay, so this thing has got two definitions. First case is if my string, let me write it, string 1, if for string 1 the ith character is same as the jth character of string 2, in that case the answer will be 1 plus LCS that ends at I mean, let us call it in this way, LCS I minus 1 comma j minus 1. What is the meaning of this? LCS of the two strings where the first string is S1 from 0 to I minus 1 and second string is S2 from 0 to j minus 1, right? And if they are not equal, then I have got two choices. The two choices are, I need to first find LCS of the two strings where first string, in the first string I am retaining its character, in the second string I am letting go off. And the second choice was to do I minus 1 comma j. And now whatever is the max of these, that would be my solution. There is no plus 1 over here. Why? Because there was no matching character found. Here the matching character was found. That is the reason there is a plus 1 over here. This thing is your actual essence behind DP. This is your recurrence relation. Okay, so you can always code this thing in form of recursion. Yes or no? Is that clear to everyone? Can you just type yes if you got what I have written on the board? Okay, now every recursive code has a recurrence relation, but it also has one very, very important thing. What is that? Yes, that is your termination condition. So can I say that, hey guys, if let's say you start with LCS of 10-10 and let's say this condition was true, okay, then you would invoke LCS of 10-9 and LCS of 9-10. and so on, it will go on and on. Can I say that, hey, the value of I comma j will keep on reducing only? Is it ever happening that you make call to a next function for a higher value of I or a higher value of j? Yes or no? It is never happening. So they are always getting reduced. So eventually what would happen is that I would become -1. What is the meaning of I equals to -1? So I was the testimony for string 1 that I am considering from 0 to index I. Now if I is -1, that means my string 1 is empty. Yes or no? Yes or no? If I is -1, that means my string 1 is empty. So if you are trying to find LCS of an empty string, you know for sure that this is empty, but you do not know what this is. This can be empty, non-empty, whatsoever. Can you tell me what will be LCS of an empty string comma some other string? Common sense says it should be 0. Is that clear to all? Right. So whenever I see that I is equal to -1, I will return 0. Similarly, if my j is equal to -1, then which string is being empty? If j is -1, that means my second string for sure is empty. I do not know what my first string is. It can be empty, non-empty, anything. So again, can you tell me what will be the answer over here? What is the length of longest common subsequence of S1 comma empty? This will also be 0. So if my I is -1 or j is -1, I should simply return 0, which are my termination conditions. And if that is not the case, then I will simply recur using this logic. Is that clear to all? How many of you understood both the recurrence relations as well as termination conditions? Just type in yes. Yeah. So now that I have these two things, I have my recursion based code ready. I can write recursion based code very easily. Okay, but are there certain overlapping problems over here? Do they exist? The answer is yes, because let's say this called ij -1 and I -1j. Now this might again call ij -1 and I -1j. And when this calls ij -1, you see that both of them are exactly the same. So it can happen that the same problem is being solved again and again. Overlapping subproblems are there. Are you able to see? How many of you are able to see the overlapping subproblems? Cool. And in your free time, when you draw this tree, you can say that there is not just one of them, there will be many of them. Many overlapping subproblems can be there. Okay. So what should I do? What should I do if I have got overlapping subproblems? How do you ensure that you do not solve something which you have already solved? Yes, I would want to memoize. Okay. And here when I am trying to memoize, how many states are there of a particular problem? Can somebody tell me how many states are there? There are 2 states. So this is a 2-dimensional DP, which is a 2-state DP, because simply LCS of I or LCS of j does not make sense, because LCS is not defined for one string. The moment you said common, what common? It should be common amongst either 2 or 3 different things, right? So you have to have 2 things, which are I and j. And the physical interpretation of I and j is that I means that S1 is from 0 to I and j means that S2 is from 0 to j. So there are 2 states over here. So, and now there can be different values of I. So I can be anything from 0 to m, because I is an index of S1. Similarly, j can be anything from 0 to n. So can you tell me how many different combinations can LCS of I comma j assume? How many different combinations can be there? There can be m into n different combinations, yes or no? Right? Yeah. So there can be m into n different combinations. So for this, I will create a memoization data structure called as LCS mn, and I can initialize everything to null. Okay. So this thing stores the answer of LCS ij. So initially I do not know the solution to any LCS ij. I have initialized everything to null. Now the moment I'll solve it, I'll put it at its respective slot so that it can be reused the next time. Did everyone understand it? Yes or no? Okay. Do you understand that how do I decide the look of my memoization data structure? Are you able to understand this? This is easy to understand. If let's say there are 3 dimensions, okay, dimension 1, dimension 2, dimension 3. If for dimension 1 there are x possibilities, if for this there are y possibilities, and if for this there are z possibilities, then the 3D array that you would want to declare to memoize the things should be of size x into y into z. Did this make sense, what I just said? Just type in yes or no. Right? So this is the way through which you determine that whether your memoization array should be 1-dimensional, 2-dimensional or 3-dimensional. Also, to generalize, it is not necessary that it will always be an array. Sometimes it can be a map also. Okay, so for convenience I am using an array. Sometimes it makes more sense to use maps, and let us see if we can discuss such kind of problem. Okay. Cool. So now I can very easily write the recursive code of this thing that I have explained, and along with the recursion I can memoize it. The moment I do that, it will be a top bottom DP. Okay. So let's say I am trying to solve this problem. So let's say string 1 and string 2 are declared globally somewhere. Just to reduce confusion in my function, I am passing just I and j, and you know what I and j are. Okay, what should come first? This is a recursive code. Okay, so in recursive code, the thing that comes first is your termination condition. And what is your termination condition? The moment any one string becomes empty, because your I and j are always reducing, they are always moving in negative direction. So the moment your I becomes -1 or j becomes -1, no matter what is the other value, you can always return 0. I think this makes sense to everyone, right? Okay. After this, what should I do? Let's say my recursion moved from here to here, here to here, then it came back here, then here, and then here. So by the time you reach here, you would already have solved this thing, yes or no? By the time you reach somewhere, you might already have solved this thing. But this is not always true, right? Like when you reach here, you cannot expect that you have already solved LCS of 9, 10. But when you are here, you might expect that you have solved LCS of 9, 9. So how to distinguish these cases? Is there a way to distinguish this thing? Is there a way through which I can check whether I have solved a problem or not? Yes, I can refer to this thing. So think of this as your database of answers. So this contains answers to a unique problem. I, j is a unique problem, 5, 4 is a unique problem, 3, 7 is a unique problem, 0, 10 is a unique problem. They are all unique problems. And if you solved something before, you would have inserted the answer of that in here at the right slot. So if I happen to see that LCS of I, j is not equals to null. If this thing is not equals to null, can I say that I would definitely have seen this thing before and solved it? Can I say that? Yes or no? I can say that, right? In that case, what should I do? I should simply return the value which is stored inside it, which is LCS of ij. Because why solve it again if this was already solved? So this is the power of memoization. Did everyone get this? Yes or no? Yes or no? Can you type that quickly? Okay, cool. So this is simple. Now if this if condition failed, it means the problem is a new problem. So this means that it was old problem, and if you come here, it means that it is a new problem. For new problem, I need to solve it, right? Now when I am trying to solve it, there can be two cases, this or this. Okay, so let us take them one by one. Let us take the first case. If my S1 of I is equals to S2 of j, it means that the last characters of the string S1 and string S2, the last characters are matching. So if the last characters are matching, in that case, the LCS of this thing will be 1 plus LCS of this smaller thing, right? So what should I do? In this case, is it wise to say that, hey, simply return 1 plus LCS of I minus 1 j minus 1? Can I return this thing? How many of you feel returning this thing here makes sense? Okay, one of you said no. Why no? And what do others feel? Yeah, so if you simply return, if let's say you simply return without storing the value of this in this LCS array, the next time you see this problem, you would need to solve it again. So the first thing that you need to do is store the solution of this and then return it. Did you get my point? Yes or no? Able to understand this, right? So the first thing that I'll do over here is I'll store the solution of this, and the solution of this will be stored in this. Guys, this is a function and this is an array. Let me avoid the confusion by renaming it to LCS. Okay, small LCS. This is a function name, this is an array, so do not confuse. Okay, yeah. So in this case, this is my function call. Okay, 1 plus LCS of I minus 1 j minus 1, and the value of this would get stored in the LCS of ij. And now I have LCS of ij, so now I can return this LCS of ij. So this was my case where the characters were matching, but what if the characters are not matching? So if your characters are not matching, in that case, you have got two calls to make. So your answer will be max of this comma this. So you can call max of LCS of I comma j minus 1 comma LCS of I minus 1 comma j. Okay, and this would be the value that you would store in LCS of ij, and after storing it you can simply return it, LCS of ij. So this is the complete code for finding LCS. How many of you got this clearly? Just type in yes if you understood the LCS based code clearly. Okay, who will tell me the time complexity over here? Any guesses on time complexity? M into n. Why is that M into n? That is important to understand. So guys, understand it for one and forever. Okay, I will not be repeating this thing again because the same explanation is applicable everywhere. So whenever you have been given a code which is recursion plus memoization, first thing you should try to see is that how many distinct problems are there. How many distinct problems are there? So can you tell me how many distinct problems are there which I am trying to solve? M into n, right? Yes or no? Number of distinct problems here are m into n. Yeah, size of DP array, very good, because each of these are problem. Here there are repetition, so I can say that hey, m into n will be the number of distinct problems that I am solving. And how much time am I taking to solve a particular problem? So that I can infer from here. So for these cases, I return something in order 1. For these cases where the thing was already solved, I return it in order 1. And even for this and this case, what I am doing, I am calling this and this, but the time taken by this will not be included in the time taken by this. That is a separate time, right? So for solving LCS of ij, I am just doing some constant operations, which is an addition or max computation. So that way I can say that everything is being solved in just order 1 time. And since there are m into n different problems and every problem is of order 1 time, so the overall time complexity will be order m into n. Is that clear to all? Yes or no? Others, did you get that? Do you have a doubt in understanding time complexity or anything? If you do not understand the time complexity of solution, that simply means you did not get that solution. Okay, you might be thinking that you got it, but you did not get it if you did not understand the time complexity. So I've seen yes from very few of you. What about others? Did you get that? Do you want me to repeat or what? Okay, so let me trust you got it. Okay, so the time complexity is m into n and the space complexity is also m into n because I need that DP array or LCS array, whatsoever it is. Okay, can I convert this into a bottom top approach? How many of you can think of converting it into a bottom top approach? Okay, so let us all understand how would that look like. So here, can I say one thing that, guys, my 2D array is of this shape. And let's say this is my I comma j. In order to find the answer for this, if this thing is true, I would refer to I minus 1 j minus 1 and this is my I minus 1 j minus 1. So if the characters are matching, to find the solution of this, I need the solution of this. And if they are not matching, then I need the solution to I j minus 1, which is this. And I also need the solution to I minus 1 j, which is this. Does this thing make sense to everyone? Are you realizing that which cell of matrix depend on which other cells? Okay, are others able to understand that? Yes or no? Okay, cool. I think it's a very easy thing to get. See, what do you see over here? If this is I minus j, this thing will be I minus 1 j minus 1, right? And this will be ij minus 1 and this will be I minus 1j, right? That is what I am saying. So no matter whether you are in if case or else case, your solution either depends on I minus 1j minus 1, which is this, or it depends upon either ij minus 1 or I minus 1j. Does that now make sense to everyone? Okay, I will proceed. Cool. So this is the definition. So what I can do is I cannot expect that, hey, I am trying to solve this thing without solving this, this or this. So if let's say I am trying to fill this 2D matrix somehow, how should I fill it? How should I fill it? Can I fill it from bottom to top? Is it possible to fill from bottom to top? What I mean by that is first fill everything here, then everything here. Can I do that? I can't do that because while you would try to do that, you would try to fill this, and for that you know this which you don't have. So doesn't it make sense to fill things from top to bottom, which is first fill your 0th row, then first row, and then at the last you fill your last row? Does that make sense or not? Okay, that makes, right? So that is the entire thing to understand here, right? So I should fill the cells in top to bottom manner. Also, for a particular row, let's say when I am filling this row, should I fill it from left to right or right to left? So I must fill it in this direction because let's say you are trying to fill this, and if you have not filled this, you cannot find answer to this. So I will fill from top to bottom in left to right manner, which is in this manner, which is also my level order manner. So guys, it is not necessary that in every problem you have to fill like this. Here, because of the nature of recurrence relation, filling the cells in this order makes a lot of sense. Is that clear to all? Does this make sense why I am filling things up in this manner? Okay, now I'll show you one case where let's say you have first string is A, B, A, D and second string is B, C, A, D. Guys, I am speaking from implementation perspective. If you will not understand this, you will never be able to implement bottom top DP, which is very bad thing when it comes to interviews because they make you implement this form. Can someone tell me why I have created this extra row and this extra column? Why I have created this extra row and extra column? Yes, to take into consideration the empty prefix of ABAD. So my string 1 is ABAD, okay, and my string 2 is BCAD. So see, my termination conditions were corresponding to the cases where string 1 was empty and string 2 was either this much or this much or this much or this entire thing, or it was corresponding to the case where my string 2 was empty and my string 1 was this much or this much or this much or this much. Are you getting what I'm trying to say? Yes or no? Right? Others, did you get that? Yes or no? So basically what happens, that the termination condition of top bottom approach acts as, you know, initial conditions for bottom top approach. So in bottom top approach, you will first have to initialize everything here, then only you can start filling from here, because you cannot expect a solution to this without knowing solution from this and this. So you have to initialize some cells, and those are your cells of first row and cells of first column. Does that make sense to everyone? You're getting it, right? Okay. Now what is the meaning of any cell? Let us understand that. Let's talk about this cell. So this cell means that, hey, if I consider this much of string 1, which is ABA, and this much of string 2, which is BC, then what will be my answer? That answer will be stored over here. That is the meaning of this cell. Did you get that? Yes or no? Did you get the physical significance of this cell? Okay. Can you tell me what should be the value that should be stored at this cell? What is the longest common subsequence of ABA and BC? Why does that take so much of time? It should simply be 1, right? Because this B is matching this B, right? So it should be 1 over here, and you will see that 1 will come over here. Okay, anyways, I should initialize everything here and here. How do I initialize everything here? So anything here means that this string is empty and the second string can be anything. So if first string is empty, no matter what your other string is, everything here should be 0. And similarly, everything here should be 0, because they all correspond to this string, which is S1 being empty, and then different prefixes of S2. Does that make sense to everyone? Just type yes or no. Right, so this way I have initialized them. Now I can start filling in the cell. So I start from here. What I'll do? First thing that I'll do is I'll check for this case. Are the two characters matching? They are not matching. So if they are not matching, then my answer will be max of this comma this. And max of this comma this is 0 only. And that makes sense because LCS of A comma B is 0 only. Okay. Similarly, now let's come over here. So here you are trying to find that what is the LCS of AB, which is this, comma B. What is the LCS of AB comma B? So you will compare the last characters, which is you will compare this with this, and you will find them same. So whenever they are same, then your answer is 1 plus LCS of diagonal value. Okay, which is the, and what does this represent? This represents the LCS of empty comma A, right? So the answer over here will be 1. Did you get that, how I wrote 1 over there? Yes or no? Right? So this way you can, just keep filling this matrix very easily. Again, you come over here. So you are trying to find LCS of ABA comma B. So you will compare A with B. They are different. So your answer will be max of this comma this, and that is 1, which is your answer. And that makes sense because LCS of B comma ABA is B. Again, when you are here, you will compare D with B. You will see that they are different. Your answer will be max of this comma this, which is 1. So this way, if you keep filling it, you will get 0, 1, 1, 1, 1, 1, 2, 2, and then 1, 1, 2, 3. Okay. Now, this is the table that you have created. Can you tell me which cell of this will be my answer? Which cell will be my answer? The last cell will be the one which will be my answer, because the physical significance of LCS Ij is that if I consider S1 from 0 to I and S2 from 0 to J, then what is my LCS? Okay, And if you want to know the LCS of complete string 1 and complete string 2, you have to consider complete string 1 and complete string 2, and that thing will reside in the bottom right cell. So this will be your overall answer. Okay, cool. So can everyone write the code to fill this matrix? Of course you will first initialize your first row and first column. After that, can you fill out all the cells? Yes or no? Should be easy enough, right? Okay, cool. So this bottom top approach is derived from this thing only, because the prime motto is to break a large problem into smaller problems, and it is easy to do that by performing recursion. And that is the reason you should be great at recursion, because if you are great at recursion, you can always apply this thing, which is recursion plus memoization. And once you do this thing, then this thing will be auto derived. Why? Because the termination conditions will help you initialize, and recurrence relations will help you fill up the cells. Does that make sense to all? I made a very important point over here, that how you can derive bottom top always from top bottom. And let me tell you, you can always do that, always. Okay. Cool. Okay. In this case, there is one very important thing. The first question of today, there I had shown you bottom top way of doing it. Okay. And there I told you that you can save space. What was the space complexity of this approach? It clearly was order m into n. And here also, you can definitely do it in order m into n space. Okay, you can declare a 2D array and you can fill all of them in m into n. But can I do it using some lesser amount of space? Can I use some less space over here? Anyone who would want to take a shot here? Okay, so I actually can. And now everyone look over here. Let's say I am trying to fill everything in this row. If I am trying to fill everything in this row, do I need to know the values of this row, or do I need to know the values of this row, or do I need to know the values of this row? Yes or no? I do not need to know, right? Are you getting it, guys? Yes or no? Yeah. So can I say that, hey, if I just know the solutions of this row, I can figure out everything in this row. That is, if you have to make ith row, you should just know the solution to I minus 1th row. Does this make sense to everyone? Yes or no? Right? So instead of using a 2D matrix, what I can do is I can have just two arrays. First will be my previous array. You can do it with one array also, but just to make your understanding easy, I am going to do this. You can have a previous array and a current array. Okay, and in the previous array you will have old values, and in the current array you will create the new values. Now you will swap your previous array to come here, and again you will change your current array to next set of things. So this way you can just use two one-dimensional arrays, which will be just order m or order n space, and then you will be able to solve it. Does this make sense to all? Yes or no? Now are you able to realize that why bottom top approach helps us save the space? Can you type in quickly, yes or no? Right, that makes us save the space. Why? Because the things are being populated in a sequential fashion. But was that the case in this top bottom approach also? No, it was not the case, because there the cells were getting filled randomly. Sometimes you were filling here, then here, then here, and so on. So there you could not use this approach of, there you could not use just one-dimensional array and solve it. So that is the reason bottom top is quite popular. I ask it again, does that make sense to everyone now? Yes or no? Okay, cool. This was a very important point, by the way. Let's move on. Okay, let's do another problem. So what I want you guys to do is, in this question you have to write 3 pieces of code. First piece of code that you should write is, you should write your top bottom DP, which is recursion plus memoization, and then you should write your bottom top DP. So here also space is mn, here also space is mn, and now you improve this bottom top DP to use linear space, which is order of m or order of n, whatsoever it is. How many rows are there? Number of columns is n, so almost order of n. So can I expect all of you to write these 3 different codes for this problem itself? Will everyone be able to write, yes or no? Cool. So please do that. That will be a good confidence booster for you. Okay. Let's move on. Now let's say the question is that I have been given a string S size n. I want to find the length of longest palindromic subsequence. Length of longest palindromic subsequence. How many of you understand the problem? Okay, cool. So I think everyone understands what a palindrome is, right? Palindrome is something which reads the same way from front to back and back to front. Okay, so let us take a very simple example. Let us say I have AC, BAD. What is the longest palindromic subsequence? What is the longest palindromic subsequence in this? Yes, very good. So ACA is the right answer, and ABA is also the right answer. So if I take ACA, this is a palindromic subsequence. You could also have taken ABA because this is also a palindromic subsequence. I am interested in the length, and both of them are having length 3, so I can just output 3. Okay. Did everyone understand the meaning of the question? Just type in yes or no. I'll give you one more example and then let's try to figure out the answer to that. So let's say the input now looks like BBA, BCB and CAB. Can you tell me the output for this case? What is the length of longest palindromic subsequence here? Just take your time, do not rush, and then think. I did not get your question. There's the same concept of substring. It was not a substring, by the way, it was subsequence. So if that is your question, then it makes sense. Okay, so I think till now 2 of you have given me the strings. One guy has given me length 6 and the other has given me length 5. Anyone who can sense a length greater than that? Okay, you can't sense a length greater than that? Yes. So how many of you are getting length 7? Many of you are getting, right? So that clearly makes sense. Okay. So what I am saying is, what if I choose this B, A, B, C, B and this A and then this B. If I do that, I'll get B, A, B, C, B, A, B. And you can see this match, this match, this match, and this is the central character. Okay. So the maximum length over here is 7. Does this output make sense to all? Yes or no? Others, are you able to get? Okay. How many of you can solve this? Think of an approach. You can discuss it with me. I mean, I can talk more about it then. I'm thinking of reversing. Okay, so one of you says that he is thinking of reversing. Okay, Praveen Tripathi is saying find LCS of given string with its reverse. So how many of you agree with that? Just type in yes. Yes, and that is an excellent observation actually. Because just think of it in this way. Let me take this example. A, C, B, A, D. If I reverse it and put that in a different string, so let's say I create string S2 which is nothing but reverse of S1. I can create that, okay, that will be DA, BCB. Then whatever will be the longest common subsequence of S1 and S2, whatever will be longest common subsequence of S1 and S2, that will definitely be a palindrome. Can I say that? Yes or no? Can I say that will be a palindrome? It will be. Why? Because just imagine that there is a string S1, okay, and you created a string S2. Now if there is a common subsequence, let's say that common sequence is A, X, Y, X and A, and there were certain characters in between, okay, and let's say here this A came here and this X came here, Y came here, X came here and then A came here. And this is for sure that because this S2 is nothing but a reverse of S1, so this A would have come here, this A would have gone here because you reverted it, right? So this thing would have gone here, this thing would have gone here, this X would be here, this X would be here and this Y would be here. So whatever would be the longest common subsequence of S1 and reverse of S1, that will definitely be palindromic in nature. Yes or no? Now does that make sense to all? Can you just type that? Right? And that itself would be the longest palindromic subsequence also, right? Okay. Why that will be the longest palindromic subsequence? Because that is the longest common subsequence in S1 and reverse S2. Okay. So, I mean, if at all, so if this was your example where your answer was, let's say A, C, A, and when you revert it, or it was A, B, A, when you revert it, then you see that this A is appearing over here, this C is appearing over here. I think this is DA, BA, BC, A, yeah. And this A is appearing over here. So you can just create another string S2, and after creating S2 you can simply find LCS of S1 comma S2, and that would be your answer. Okay, is everyone clear with this approach? Cool. Is there a different way to solve this? Can I solve this question differently? Because to solve this here you created a separate string. Let me tell you that, hey, I am not going to allow you to create a separate string. Can you solve it now? Okay, so one of you says you can do it, and guys, that is a very important way. So look at the board and understand how we can do that. So let us say I have string S1 which comprises of A followed by something something something, and its last character is also A. So let's say this is my ith character, currently I is 0, and this is my jth character, currently j is n-1. Okay, so I want to find the longest palindromic subsequence of S1. This is what I want to find. If first and last characters of the string are matching, can you tell me what will be the answer? Okay, so somebody said n, and that is very stupid, I guess. What about others? Do you believe it will be n? It is not necessary, right? Because I can have a string S1 like this, where the first character is A, last character is A, and in between you have C, S, Q, R, something like this. Can you tell me what is the longest palindromic subsequence here? What is the longest palindromic subsequence here? Yes, so many of you are able to give me the right answer. That is very impressive. What is the longest palindromic subsequence here? A, C, Q, X, Q, R, A. Can you tell me the length? Okay, I'm not sure why is that taking so much of time. That should just be 3, right? It should just be 3. And if you take a look at this 3, what is this? This 3 is basically, because this and this were matching, so I took 2 contributions of it, plus then I found the LCS of the sandwiched area, which is from I plus 1 to j minus 1. Does that make sense? Yes or no? Others? It makes sense, right? So this is the way in which you can recurse from LCS of ij to something which is equal to this. Now my question is that what is the physical significance of LCS ij here? Guys, the day you understand how to talk about this thing, that what is the physical significance of dpij in different problems, solving the problem will be very easy for you. So will it have the same significance as the last problem, or will it have a different significance? Just type in same or different. Will it have a same significance in context to this, or will it have a different significance? Can you quickly type that out? Yeah, it should have a different significance, right? Because in the last question, the significance of this was that, hey, S1 is from 0 to I and S2 is from 0 to J. Guys, here there is no S2, here there is just S1, right? So this must be different. And what is it? So I'll tell you that. That is LCS of ij means, okay, I'll not call it LCS, this is LPS basically, longest palindromic subsequence. LPS, longest palindromic subsequence. So this thing means that, hey, if let's say my original string is this, and if I am considering the portion from I to j, what is the longest palindromic subsequence in this portion? So that answer will be stored in this. So LPS of ij means that I am considering the portion of the string from I to j, everything else is useless to me. Okay, then what is the longest palindromic subsequence within this? So I think if I take a look over here that is B, P and whatsoever that is, I think that is PP, that is just P and P. So the longest palindromic subsequence for this is 2, right? And that makes sense, because if I consider the portion of the string from here to here, then 2 is the maximum length that I can get. Is everyone clear with this now? Did you understand the definition of LPS ij? Everyone, yes or no? Right? Yeah, because the definition is like that, it allows me to change it in this way. Okay, cool. Now another thing that I want you to answer me is that, is it necessary that if both the characters are matching, then whatever will be my answer, it will definitely have an A over here and the other A over here, and then something sandwiched in between? Will it always be the case? Yes or no? The answer is yes, it will always be the case, because let's say even if you had something like P, Q and then let's say BB over here, so in this much portion the longest palindromic subsequence is BB, and I can append this A before BB and I can append this A after BB. Okay, sometimes what can happen is you can have something like AXAA. Can you tell me what is the length of longest common subsequence here? Sorry, longest palindromic subsequence of this thing, AXAA. It is 3, right? It is AXA. Now that AXA can be gotten by considering this, this and this, or considering this, this and this also. Yes or no? Yes or no, right? But I told you that, hey, the moment they are matching, I am quickly taking their contribution and moving to this much part. Can I do that? Or do you feel it might fail for such kind of cases? How many of you feel I can do that? Yes, AAA is also there. That's a different story, but right now let's focus on AXA. So that will make the intent very, very clear. So the point to understand over here is that, hey, if let's say this along with something in between created a palindrome, it meant that this thing was matching with this thing. Now I can skip this thing, and still let this to match this, because both of them were equal in the first place, and still this will remain in between. Did you get my point? How many of you got it? Say yes. Is that clear, guys? Yes or no? Okay, do you want me to repeat here? Yes or no? Okay. So A, X, A. So I can have this also, and I can have this also. Yes or no? Yes or no? Quickly. I can have, right? Corresponding to this case where my I was at this A and J was at this A, would you consider this recurrence relation or not? No responses. You would consider, right? Because both of them are matching. And the moment you write this recurrence relation, this 2 is for the 2 A's that you had got. Can I say that? Yes or no? This 2 is for the 2 A's that you had got. But now here I am saying that, hey, I could have taken this A also with this A. Now what I said that it might be possible that there are different palindromic subsequences of the same length. But if such situation arises where the border characters are matching, I will definitely have one solution corresponding to this, because let's say I have an AXA over here. Let me make it more generic. Let's say you have ATX ABA. Okay, still here either AXA or AX, this A will be my solution. So if you consider this much of part, you said that, hey, what I can do is that I can simply take this much part from here, okay, take this much part from here, and then say that, hey, this XA is matching with this A. Now one thing to understand here is that if you had an X over here and you had an A over here, the reason AXA is creating palindrome is because this thing was matching with this thing. But can't I say that, hey, if this thing is matching with this thing, because these two characters were equal in the first place, this will also match this thing. So I could have let go of this A from here, and I could have simply allowed this AXA, and this would also have had the same length as the earlier AXA. Now does that make sense? Yes or no? Right, so that is the point. This is just like LCS. In LCS I questioned you that the moment they are matching, why you should always let go of I and J both. This is exactly like that. Were you able to correlate that? Yes or no? So guys, you should always have answers to why you are making the different transitions. If you do not have, that means you cannot prove why this is right or why this is wrong. Okay, cool. So I think this was the case where the characters were matching, but what if they are not matching? If let's say I had a B over here, in that case what will be the recurrence relation? Can somebody think of it? And the hint is it will be very, very similar to the LCS thing. Guys, can you quickly do that? Yes. So in that case I can say that, hey, my longest palindromic subsequence, it would either be something from here, which would either be a subsequence of this portion, or it would be a subsequence of this portion. The first case corresponds to I j minus 1, and second case corresponds to I plus 1 j. Does this make sense? Yes or no? Guys, does this make sense? Yes or no? Can I say that? Can you repeat the equal condition? Why do you want me to repeat that? I think that is very trivial. So in this case, my answer will be max of LPS of I comma j minus 1 comma LPS of I plus 1 comma j. What is I comma j minus 1? If I consider the portion from here to here, then what is my answer? And what is I plus 1 comma j? If I consider the portion from here to here, then what is the answer? Okay. Okay, because somebody wanted me to repeat that, I am repeating it again. I think so. The last two characters are matching and there is something in between. Can you not always take the contribution of these two last characters if they are matching? In equality case, if the last two characters are matching, can you not always take the contribution of them? Would someone mind typing it? Yes or no? You can always take that, right? And I told you why you should take that. Now the moment you take that, you have got two characters with you which will act as your front and rear. Now everything else can come from in between. Now if let's say in this between area the maximum length subsequence was, let's say, BCX CB, then you can put this thing in between this, and then this will be the answer for overall string. Okay, cool. Yeah, who will tell me the edge cases for this? By that I mean termination conditions for this, because I think recurrence relations are very easy. Recurrence relation simply says that I want to find the longest palindromic subsequence from I to j. There are two cases. If Si is equal to Sj, then this is 2 plus LPS in I plus 1 to j minus 1. And if not equal, then that is maximum of the two things. The first thing is LPS from I to j minus 1, and second thing is LPS from I plus 1 to j. What will be the termination condition over here? Yes, very good. Don't you think that I and j both are coming closer to each other? The way recursion calls are happening, I and j both are coming closer to each other. Yes or no? So eventually what would happen is that I and j both might become equal. Don't you think so? Yes or no? Yes or no? Both of them might become equal. So let's take an example. If you have something like BAB and you were here and here, so you are trying to find LPS from index 0 to 2. What would be the expression for this? You found that there is a match, so you would say your answer is 2 plus LPS from here to here, which is from 1 to 1. So if you see that both the indices are matching, then you are saying that, hey, you are considering a substring of length 1 and you are trying to find that what is the longest palindromic subsequence in this. So what is the longest palindromic subsequence of a string whose length is 1? Can I say it will be 1 only? Because any one length string itself is a palindrome. Yes or no? Does that make sense to everyone? Right? Yeah. So the moment I see that if I is equals to j, I can simply return 1. Okay, but there can be some other termination condition also. Can anyone figure that out? Can I have some other termination condition over here? Yes. How many of you agree with Harshit Garg, that I can become greater than j? Let us take this kind of case. AA. Here, when your I was here and j was here, you will see that both of them are equal, and you will now call LPS of I plus 1, j minus 1. Your I was 0, j was 1, and after doing this your I will be 1 and j will be 0. Do you see this? How many of you see this? Just type in yes. Right? So what does this mean? Again, what is the, like in earlier question, the value of I equals to -1 was S1 is empty. So here, whenever I becomes greater than J, what does this physically represent? Can I say that, hey, this represents an empty string? Because this will only happen in such kind of cases that now you're trying to see that, hey, this portion is palindrome or not, and this portion is empty. Did you get my point? Yes or no? Yes or no, right? So whenever your I is greater than J, then that would imply that you are considering an empty string and you are trying to find the longest palindromic subsequence in that empty string. So can you now tell me the longest palindromic subsequence, the longest palindromic subsequence in an empty string? It will be 0, right? It will definitely be 0. Is that clear to everyone? Yes or no? Okay. Yeah, so there are two termination conditions that I have to take care of. First termination condition is where my I is equal to J. So I will return my answer as 1. And if my I is greater than J, can I say that, hey, I greater than J, it is same as I equal to J plus 1. Because the moment they take each other over, I becomes J plus 1. Yes or no? Can I say that? Right? So both of them are same, right? Because I will never allow I to become J plus 2. Either I will terminate at I equal to J, or I will terminate at this thing. Okay, so the moment this thing becomes true, I will return 1. The moment this thing becomes true, I will return 0. Clear to all? Are you able to understand? So guys, if you see carefully, I take my input, then I think of the different cases that can arise. The cases can be that there is a match or mismatch, and corresponding to different cases there are different recurrence relations. So first I come up with recurrence relation, and then taking a look at how the indices are moving, I can come up with the termination conditions. Once I have my recurrence relation, termination condition, then I can always memoize, and I can write my top bottom DP. Is that clear to all? Now tell me how many of you can write the top bottom code for this on your own. Just type in yes or no. Everyone, can you write the top bottom code? Yeah, you should be able to write it with ease. Okay, so let us write it actually. So this is, by the way, second approach of this question. First approach was LCS based, that was very easy. So let's say int LPS I and J. Okay, so first I'll write my termination condition. If I'll see that my I is equal to J, that means this is the case where I am considering just one length substring and trying to find longest palindromic subsequence in that. So that will be the string itself. I'll return its length 1. The other case can be where my I overtook J. So that will correspond to this situation. If my I becomes J plus 1. You can write it as I greater than J also. It's totally up to you. In this case, what should I return? What should I return? I should return 0, right? Cool. Okay. I had written last code, so I would say after writing the edge conditions, what should come? After writing the edge conditions, what should come? It means that now I have a problem which is not a terminal problem. So there can be two cases. Either I have solved it before. No, recurrence relation is not the right thing. First I need to check whether I have solved it before or not. And if I have solved it before, I should simply return the answer. And if I have not solved, then I should try to solve. Did that make sense? Just type in yes or no. Yeah, so that is a very important thing to do. Can you tell me if I am going to take, again let me call it small LPS. If I am taking a memoization array for this, LPS, what should be the size of this? The string size is n, so what should be the size of this? It should be n into n, yes or no? Right? Because your I is an index of this string which can go from 0 to n minus 1, and j is also an index of the same string which can go from n minus 1 to 0. Did everyone get the reason behind creating this 2D memoization data structure? Can you guys type yes or no if you got that? Got it? Right. Okay, cool. Now another thing to understand here is that I will check whether this problem was solved or not. So if I see that LPS of ij is not null, then I will simply return the value stored in LPS of ij. Otherwise, it means that LPS of ij is a new problem, so I need to solve it. So there are two cases. If I see that string of I, if the ith and jth character are matching, in that case my solution will be 2 plus, call the same function for I plus 1 j minus 1 and store its value in LPS ij and then return this LPS ij. Return this. Did first case get clear to everyone? Yes or no? How many of you can write the else condition on your own? Can you write the else condition on your own? Yes or no? You can do that, right? Okay, cool. Okay, so now guys, I have an interesting question to ask over here. Let's say my n was equal to 4. So this would be my matrix. Do you feel that this cell would ever get filled? Would this cell ever get filled? So every time your I comma j is such that your I is either greater than equal to j or your I is equal to j plus 1. So if you are considering a substring, you cannot have a substring from index 3 to index 0. Yes or no? Did you get my point? Can you have a substring from index 3 to index 0? You cannot have. You cannot have a substring from index 3 to index 0. First index starting point has to be lesser than equals to the ending point. In the worst case, it will be I equals to j plus 1, and I told you why will that be. Are you able to get? How many of you are able to understand my point? Just type in yes. The starting point will always be lesser than equal to the ending point, right? Did everyone get that? Right? So which cells are going to get filled? Can I say that, hey, only and only these cells which are in the right triangular part, upper triangular part, they will be getting filled? Can I say that? Yes, upper right triangle. How many of you can sense this? Right? Only they are. Guys, what about others? I think I have repeated it. Are you able to get this thing? It's quite important thing to understand. See, you are using some data structure. It's your responsibility to know that which cells are getting filled and which are not. One more thing, that apart from these cells, this and this would also get filled, because although not in this case, but if I am using bottom top approach, I would want to fill these also, because these corresponds to this case where my I is equals to j plus 1. Yes or no? Others, are you getting it? Okay. Yeah. So they will actually get filled. Now, how many of you can convert this thing into bottom top? Okay. Anyone else? Okay. So let us see how can we convert it into bottom top. So when we are converting a solution into bottom top, then we fill the table one by one. Your termination conditions corresponds to the initializations. Do you remember this? Do you remember this? Yes or no? Right? So what is the first thing that I should do? Okay, do others not remember this? I had told it just before, so I'm not able to think that why you don't remember this. If you don't remember this, I can skip it and move ahead. You remember this? Okay. So your termination conditions corresponds to the initialization. So if at all you are using a 2D array, which cells will you fill first? If you have this, what should be the values that should be put in diagonal? This is 0, 0, this is 1, 1, this is 2, 2, this is 3, 3. So if I have something like A, B, C, A, then 0, 0 means this substring, 1, 1 means this substring, 2, 2 means this means this. So this cell means this substring, this cell means this substring. Are you getting my point? Yes or no? So can I initialize every diagonal element to 1, 1, 1, 1 each? Yes or no? I can initialize, right? And one more thing, what about the empty cells? The empty ones, which are this much, this much, this much, are these cells. So they can be initialized as 0, 0, 0 each. Yes or no? Yes or no? I can do that, right? Okay. Now if you take a look at recurrence relation, then my answer of LPS ij, it is dependent upon I plus 1 j minus 1. So if this is ij, can I say this is the cell which is I plus 1 j minus 1? Right? Okay. And in the second case, it depended upon I plus 1 j and ij minus 1. Now if this is ij, can I say that this thing is I plus 1 j and this thing is ij minus 1? Guys, it's basic 2D array kind of manipulation, right? Cool. That is the reason I am filling my matrix in a diagonal fashion, because you need to fill this diagonal to be able to fill this diagonal. See, if this diagonal is filled, you can always fill every member of this diagonal, and then every member of this diagonal, and then every member of this diagonal. Can I say that every member of this diagonal is a one length substring? Yes or no? And every member of this diagonal which goes from here is a 2 length substring, because what is this? This is 0, 1. 0, 1 is the substring from 0 to 1. What is this? This is 1, 2. So this is this substring, and the third one is this. Similarly, do you see what I'm saying? How many of you see what I'm saying? Just type in yes. Right? So first you initialize solutions to all the substrings of length 1, then all the substrings of length 0, then all the substrings of length 1, then 2, then 3, and then the final substring of length 1. So you can always come over here. Once you are here, you will compare Si and Sj, and if this is the case, then your answer will be 2 plus this thing, and if this is not the case, then your answer will be max of this comma this. Similarly, after filling this, you will fill this, then you will fill this, and then the next diagonal. So now how many of you can write the bottom top code? Just type in yes. So can I assume that now you guys are, so how many of you got clarity on how to relate top bottom and bottom top? Okay, this is quite a very important thing. Okay guys, so these were some really important problems on strings which are asked in DP. We will be doing one more very popular problem, but before that I think we have covered something, and I want you guys to just ramp up a bit before we move on to next question. Do you guys want a break of 2 or 3 minutes before we learn something new? Okay, so just 2 minutes. Okay, so I have the stopwatch with me. I'm just giving a break of 2 minutes to freshen yourselves. So freshen yourselves up, and then we will do something else. Okay. Okay, so we are going to start now. Just let me know if you guys can hear me. Please, someone type in yes if I'm audible. Okay, great. Let us start. So now that we have seen many variety of questions over here. Okay, by the way, would anyone mind telling me the time complexity here? Should be easy. How many operations did I do over here? No one? Okay, n square. Anyone else who feels it will be n square? Okay, approximately how many problems I have solved? Can somebody tell me? See, total number of squares is n square, right? Total number of cells is n square. And I have filled some part of it, which is almost half of it. So can I say that I have solved almost order n square problems? Can I say that? Yes or no? Right? I have solved almost order n square problems, right? And to solve any problem, I have taken just order one time. Even if you look at the bottom top approach, first you initialize and then you fill every cell in order one time, and you have filled order n square such cells. So the time complexity will be order n square only. Is that clear to all? Yes or no? Others, did you get that? Everyone got that? Okay. Okay, let's move on. Let me ask you a simple question. How many of you know how to multiply two matrices? Just type in yes, those of you who know how to multiply two matrices. You know it, right? Okay, I think that's a high school mathematics, so should be knowing. Let's say there is a matrix M1 and there is another matrix M2. So this matrix is of dimension 10 cross 5 and this is of dimension something cross 9. Can I always say that M1 and M2 will be multipliable? Can they always be multiplied no matter what are their dimensions? No, right? So in order for multiplication of this matrix and this matrix to happen, the number of columns here should be equal to the number of rows here. Yes or no? Do you remember this thing? Right? And what is the dimension of the output of their product? So if you take the product of this and get M3, what is the dimension? Is that 10 cross 9? Yes, it is, right? So to generalize this thing, if M1 is P cross Q, M2 has to be Q cross R. And the result will be P cross R, right? This is the generalization. Okay, cool. Similarly, if I extend it that, hey, if I have to do M1 into M2 into M3 into M4, then if this is P cross Q, this has to be Q cross something R. Now if this is Q cross R, this has to be R cross S, and this has to be S cross T. Does this make sense what I have written? And what will be the result of the continuous product of these matrices? What will be the result of their continuous product? It will be P into T, right? Yeah. So I think all of you are very, very clear with how matrices are multiplied. Cool. Let me ask you one question. Let's say there is a matrix M1 and there is a matrix M2. This is of dimension P cross Q and this is of dimension Q cross R. Can you guys write code to perform this multiplication? Write a computer program to do this? Yes or no? Okay. What will be the time complexity of that program? Your answer should be in terms of P, Q and R. There is no N over here. So please answer in terms of P, Q and R. Okay, so Vibhor says P into Q into R. So how many of you agree with P into Q into R? Yes, and that is correct. That is correct actually. So I think it's easy to understand, because if let's say there is one matrix which contains A0, A1, A2, A3, A4, A5, A6, A7, A8, and this is being multiplied with another matrix. Now of course the number of columns over here is 3, so number of rows here must be 3. So let's take a case where I have B0, B1, B2, B3, B4, B5. Answer me one thing, are these two matrices multipliable? Yes. Whenever multiplication happens, you take this row and you multiply this row with this entire column and then this entire column. So the product of this and this gives me something over here. Then the product of this and this gives me something over here. Then again you take this, multiply this with this and then with this. So you get these two more and then these two more for this. This is how multiplication happens. Now can you tell me, if you pick a particular row, can I say that, hey, this row touched all the elements of this matrix? Yes or no? Any row of first matrix touched all the elements of second matrix. And how many elements are there in second matrix? Q into R. So for single row there are Q into R operations. So for P rows there will be P into Q into R operations. So the complexity of multiplication is order of P into Q into R. Does that make sense to everyone? Just type in yes or no. Others, are you perfectly clear with this? Okay, cool. Let's move on. So let me tell you what is the original problem. The problem is not to multiply matrices, obviously, because that would be a very simple problem to solve. The problem is that I have been given n matrices and they are multipliable. So they are multipliable in a sequence. You can multiply M1, M2, M3, M4, M5 and so on, right? So let's say you have M1, M2, M3, so on till the last matrix, which is Mn. Okay, and I already told you that they are multipliable. Since I told you they are multipliable, so it is obvious that if this is P cross Q, this is Q cross R, this is R cross S and so on and on. Now the thing is that you have not been given the entire matrix. You have just been given their dimensions. So just think of it in this way, that there are two arrays. So first array contains the first dimension of every matrix and second array contains the second dimension of every matrix. So the values over here will be PQ, here it will be QR, here it will be RS, here it will be ST, and then so on and on. Just type yes if you understood the input. Everyone got the input? Okay. So let's say this is your input. Now, of course, because of this input, the matrix are multipliable, because this Q is equal to this Q, this R is equal to this R, this S is equal to this, and so on and on, right? So you have to tell me the minimum number of operations required to multiply all the matrices. Minimum number of operations required to multiply all the matrices. Now I am just going to give you an example for this. Let's say, everyone focus on the board. What I am writing, just focus there. Let's say you have M1, M2 and M3. These are your three matrices. Let's say the dimension of this is 10 cross 30 and this is 30 cross 5 and this is 5 cross 60, and I am multiplying them to create the result matrix. Can somebody tell me the dimensions of the result? It should be 10 cross 60, right? Yeah, because the moment you multiply M1, M2, your result will be 10 cross 5, and the moment you multiply the result of this with this, the result will be 10 cross 60. So this will be a 10 cross 60 matrix, right? Now there are multiple ways, I'll not call it ways, there are multiple orders in which the multiplications can be performed. First way is to multiply m1 m2 first and then multiply the result of this with m3. Second way is to first multiply m2 m3 and then multiply the result of this with m1. So are these the different ways or not? Yes or no? They are clearly the different ways, okay, because the order of multiplications are different in them. But can I say that whether I use this order or I use this order, my answer will have this dimension only? Can I say that? Okay, somebody said no. That should be yes, right? It does not really matter how you multiply them. If you are multiplying them and you are getting the same result, the dimensions should also be same, right? Even if you multiply these two first, you will get a 30 cross 60 matrix, and when you multiply a 30 cross 60 with 10 cross 30, you will get 10 cross 60, right? So the order of multiplication doesn't matter as far as the result is concerned. Result will always be the same. Is that absolutely clear to all? Yes or no? Right? Okay. But will the number of operations differ? Will number of operations differ? How many of you feel it will differ? You say yes. Okay, so let us check that. Can somebody tell me the exact number of operations over here? And then we will do for the second thing. So first tell me the exact number of operations if I first multiply m1 m2 and then the result of m1 m2 with m3. Tell me the exact, use your pen and paper. Without pen and paper you can't do. Take your pen and paper and tell me exact number of operations. You know that if you multiply p cross q with q cross r, operations are p into q into r. So use this fact to come up with the solution. Okay, how many of you are getting 4500? Those of you who are getting 4500, that is perfectly correct. Okay, so look at the board. Okay, hold. If you could not do till now, look at the board. It should have been done. If you are multiplying m1 and m2, okay, then you are multiplying 10 cross 30 with 30 cross 5. What will be the cost of multiplying this? The cost of multiplying this will be 10 cross 30 cross 5, right? Now the result of this will be a matrix which is of 10 cross 5. Now when you are multiplying a 10 cross 5 matrix, which is the result of m1 m2 multiplication, with m3, the cost of that will be 10 cross 5 cross 60. So how many of you understood this expression? Just say yes. Did everyone understand this expression? And what is the value of this sum? So if you sum it up, I think it comes out to be 4500. Okay, now I want everyone to tell me the answer for second case. If I go after second case, then what is the total number of operations that are happening? $27,000. Is that really 1000 or is that 100? I mean, I might be wrong, I don't know. Is that 27,000 or 100? Is that really 27,000? Okay, so let us see. So first I multiply m2 m3. If I multiply m2 m3, the cost will be 30 cross 5 cross 60. So it will be 30 cross 5 cross 60. Okay, and the result of this will be a matrix of dimension 30 cross 60. Now if I multiply 30 cross 60 with 10 cross 30, then the number of operations will be 10 cross 30 cross 60, and I think this comes out to be 27,000, which you are typing. So did you see that the order of multiplication had a drastic impact in terms of the result? Did you see this? Yes or no? Right? So this is a very important point, and now the question is very simple. Question is that You don't have to tell me the way in which you have multiplied. You don't have to tell me the order in which you have multiplied the matrices. You simply have to tell me what is the minimum number of operations in which I can multiply the two matrices. So in context of three matrices, I just had two ways, yes or no? In context of three matrices, I just had two ways, first way and second way. And so if this would have been my question, then my answer would have been 4500, right? But if let's say there are n matrices, then there can be many different ways. Do you realize that? Yes or no? Yes or no? Yeah. So out of all those ways, the way which gives you minimum number of operations, that I am interested in. So is everyone clear with the question? Just type in yes or no. Okay, it is a very good question, and there are certain good variations of this problem out there. Okay, so if you understand this, then chances are high that you should be able to solve others also. So think how you can solve this. And if somebody has an approach, he can say yes, then I can discuss that with you. Okay, so let us take a look. How many different ways can be there? I'm just taking an example where I have 5 matrices. So let's say I have M1, M2, M3, M4, M5. Guys, everyone look at the board. Just leave everything and focus your attention here. See, one way of multiplication can be first multiply this and then multiply the result of this with this and then multiply the result of this with M4 and then multiply the result of this with M5. Can this be a way or not? Yes or no? Okay, somebody is saying we can put the input in vector of pairs and sort them. Does not make sense. First thing, when you sort them, then the order will be changed. You cannot multiply P cross Q with R cross S. So sorting is not going to help, and also sorting and then multiplying will even not ensure that you will get the most optimal answer. So see, what is dynamic programming? In dynamic programming, you are not sure that which transition is going to give you the best possible solution. Whenever you are not sure about it, then you take all the possible transitions, like how you were doing in LCS. The moment you saw that there are two choices, you took both those two choices, right? So this is like recursion only, where you exhaustively search all the solution space and then you memoize, because you want to optimize it. You do not want to do things again, and then you memoize. That is what BP is. So can you just try doing that thing over here? Okay, so if you understood this example, another example could have been, I would first have multiplied M2, M3, and then I would multiply the result of that with M4, and then the result of that with M1, and then the result of this with M5. So this is different from this approach. So are you able to see that there are different approaches of multiplication, and all of them will incur different costs? Yes or no? Right? You must be able to say. So how to tackle this problem? How to first decide, I'm going to write it down, how to decide the number of choices at any step. How do I decide how many choices do I have at any step? Because See, in LCS, when the characters did not match, you had two choices, ij minus 1 or I minus 1j. Similarly, here also you have multiple choices. If you are able to figure those choices out, then your job becomes done. Okay? And think of it recursively and think of it in terms of breaking a large problem into smaller problems. If you are able to think like that, then your job becomes done. Okay, I have a solution. We can take all the matrices at left of iterator as one set and right ones as another. And one of you said n minus 1 choices. So guys, how many of you understand whatever is written on the board? Just type in yes if you get that. Okay, so let's take a look over here. So what I'm trying to say is that how many choices I have for partition. Let's say there are 4 matrices, M1, M2, M3, M4. See, first what you do, you partition this single chain. I'm going to call it a chain, okay? I partition this single chain into 2 different chains of length x and n minus x, right? What I mean by that is, first x matrices will be in the left chain and remaining n minus x matrices will be in the right chain. Are you getting my point? Yes or no? Others, are you getting this? Yes or no? Right? Yeah. So one way to partition would be to just have M1 in the left chain and to have M2, M3, M4 in the right chain. Now this multiplication is independent from this multiplication. So this will have a different cost. This will have a different cost. Okay. Similarly, another way of partition could have been, I would have kept both M1, M2 here and M3, M4 over here. Does this make sense? Will there be a third way also? Will there be a third way also? If yes, can you write it on the chat? What will be the third partition? I mean, which set of matrices will be your left and which set of matrices will be your right? Yes. So the third and last way can be where you choose to put these things in the left, M1, M2, M3 and M4 in the right. These are the 3 choices that you had at this level, because here your n was equal to 4. Does this make sense to all? Yes or no? Make sense, right? Okay, cool. So this is the first thing. Okay, can I say that if the number of matrices involved in my chain is n, then the different choices that I have are n minus 1. Can I say that? I can say that, right? So that is the first thing to understand. Okay. Now I'll ask you a very simple problem. Let's say you chose to go with this. Let's say you chose to go with this. And let's say these 3 matrices got multiplied and you got an output from here, output 1. The output of this will be this matrix M4 itself. Let's say the cost of this multiplication was C1 and cost of this multiplication was C2. Then what will be the overall cost of multiplication? Will it be C1 plus C2? Will it be C1 plus C2? Okay, one of you feel it will be C1 plus C2. How many of you feel C1 plus C2? It will not just be C1 plus C2. It will be C1 plus C2 plus something else. Why something else? Because C1 is the cost of this independent multiplication. C2 is the cost of this independent multiplication. But now there is a final multiplication also of the result of this and the result of this. Are you getting my point? Yes or no? Yes or no? So Ujjwal, see, you are not clear with how matrices are multiplied. You cannot multiply M1 with M4. So one of your friends is asking me, can I keep M1, M4 in left and M2, M3 in right? What do you guys have to say? Is it possible to be done? It's not possible to be done, right? Why it's not possible to be done? Because their dimensions are not like that. The dimensions are not like that. The dimensions are such that only the adjacent multiplications can be performed easily. So I hope you get this thing. Okay. Cool. Yeah. So now the point to understand over here is that there will be one additional cost also, and that additional cost will be the cost of multiplying O1 with M4. So let's say the dimension of O1 that I received after multiplying these three was P cross Q, and if this was Q cross R, then can I say that this thing will be PQR? Can I say that, guys? Yes or no? Right? Yeah. So this will be the overall cost. Okay, and I hope you get that. So let's see how things are going to look like. So let's say I have to multiply these four matrices, M1, M2, M3, M4. Everyone just keep looking at the board, okay? So I have got four matrices to multiply. So at any point of time I have a chain of matrices, and the chain has a left bound and a right bound. So I can call this my 0th matrix and I can call this my third matrix. So let's say I want to find the answer, which is the cost of minimum cost of multiplication from index 0 to index 3. I've got multiple choices over here. Okay, first choice is where I can create a chain of this much and multiply that with this much. Second choice is chain of this much with this much. Third choice is chain of this much with this much. So there will be three choices coming down the line from here. Is everyone able to make sense out of what I am saying? Just type in yes. Others, are you getting that? Yeah. What will be the first chain? The first chain will be where I am trying to multiply. Okay, I am not going to write this again and again, it will be redundant. Okay, where I am trying to multiply from 0 to 0, and then I am trying to multiply from 1 to 3. So whatever is the cost of this plus the cost of this plus the cost of multiplying this and this. Let's say the cost of multiplying this and this is something which is x1. I'm just writing x1. So this is one thing, this is one possibility. Second possibility is I grouped 0 and 1 together. Okay, so the cost of multiplying this plus the cost of multiplying from 2 to 3 plus the cost of multiplying the result of this with this. So let's say that cost is x2. The last one would be cost of multiplying from 0 to 2 plus cost of multiplying from 3 to 3 plus x3, which is cost of multiplying this and this. Did everyone get these transitions? Yes or no? Okay, let's say the overall value of this is A, the overall value of this is B, and the overall value of this is C. Then what will be my answer for this? I need to find the minimum cost of multiplication. So what will be my answer for the original solution if I know solutions to this problem? Can anyone quickly tell me that? It will be minimum of A comma B comma C. Is that clear to everyone? Just type in yes. Yeah, so that is how it looks like. Okay, cool. I think now we can go ahead from here. So let me write it in a bit clean way. This is 0 to 0 plus the cost of 1 to 3 plus that x1. Okay, now this is a function call, this is a function call, this, these are function calls. What will you do here? What is the meaning of this? So what is the meaning of answer ij? What is the physical interpretation of this? The physical interpretation is that if the chain of matrices that I have are from matrix I to matrix J, then what is the minimum cost of their multiplication? This is the physical interpretation of answer I comma J. Does this make sense to everyone? Yes or no? Make sense? Right? So what should be the answer of 0, 0? My I and J both are 0. What are x1, x2, x3? I told that before, right? That is the cost of multiplying the output of this with the output of this. This will have output, this will also have an output. When you multiply, the cost of that will be some constant x1, right? Okay guys, my question to you is, what should I return for this function call? What should be answer of I to I? You want to multiply chain of matrix from I to I. So what should be the result of that? Should that not be 0? There is just one matrix. Can you multiply it with anything else? No. So should you not return 0? Just one of you have replied. What about others? Right? So here in this case, I should return 0. Is that clear to all? Yes or no? Okay, I'm asking it again. Clear? Cool. So this corresponds to my termination condition where I'll return 0. Okay, what will you do here? Here you will do the same thing which you did here. So you have matrix 1, matrix 2, matrix 3. How many partitions can be done? This is the first style. This is the second style. Did you follow me here? Yes or no? What I said? Yes or no? Right? So again, what would happen? When you are here, then corresponding to first call, you could call from 1 to 1 plus 2 to 3 plus the cost, and let's say that cost was x4. And the second choice that you had was 1 to 2 plus cost of 3 to 3 plus some cost x5. Now the call from here comes here. Again, this will be a termination condition. You can return a 0 over here, right? Whenever I is equal to j, you would return 0. That will be your termination condition. Now you are here, okay? So you have M2, M3 with you. So how many styles do you have? You just have one style, right? If you have got n matrices, you have got n minus 1 style. So if you have got 2 matrices, you just have got one style. And what is that? You will simply call one thing, which is 2 to 2 plus 3 to 3 plus the cost of multiplying M2 with M3, which could be some x6. Now, do you realize that 0 plus this x6, it will be 0, right? Because this is termination and this is also termination, is the actual cost of multiplying M2, M3, yes or no? This is the actual cost of, this is the actual minimal cost of multiplying M2 and M3. Guys, do you realize this? Yes or no? Right? And hence that is the value which gets returned over here. Okay? So basically this x6 comes here, this x4 comes over here, and this is 0. So that gets returned to this. Similarly from here something will get returned to this. And that is how it will all, propagate down the line. And you will keep on taking the minimum, and that will be your answer. So how many of you got this approach? Just type in yes, those of you who understood the approach clearly. Okay, now I am going to write the recurrence relation for this. So recurrence relation looks a bit scary, but that is very easy to understand. That is not a tough thing. Okay, so I want all of you to take a look. Okay, let me tell you one thing. Let's say the input is given in such a way that M of I is a pair. M of I contains two attributes, rows and columns. So Mi dot R tells me how many rows are there in ith matrix, and Mi dot C tells me how many columns are there in ith matrix. Does this make sense to all? Yes or no? Others, are you following this, right? Okay, so I'm saying this just for my convenience of writing. Okay, cool. So if I have to know the minimum cost of multiplication from I to j, what will it be? So termination condition is known, right? Termination condition is that if I is equal to j, in that case answer ij must always be 0. Is this true or not? Yes or no? Can you type that quickly? Is this true or not? Right? Cool. But if that is not the case, then depending on the length of this, so the length of this is j minus I plus 1. So there will be j minus I different function calls, and I have to literally invoke those function calls, and I have to take the minimum of them, and that minimum will be the answer for this. Are you getting my point? Right? So how am I going to do that mathematically? So I am going to say that let's say I pick a point k. I pick a point k in between, somewhere in between I to j. Okay? So in that case, the cost will be answer from I to k. See, when I picked the point to be 1, it was answer from 0 to k, which is 1, and then answer from k plus 1 to here. So answer from I to k plus answer from k plus 1 to j plus one more thing. And what is that? That will be the cost of multiplying this and this. And the cost of multiplying this and this will be number of rows in this multiplied by number of columns in this. So basically number of rows in this matrix, ith matrix. So it is mi dot r multiplied by number of columns in this matrix, which is mk dot c multiplied by number of columns in this matrix, which is mj dot c. So if you split this around k, then this is the overall cost, and this is nothing, this is this thing that I have written. So first thing corresponds to the first partition, second thing corresponds to second partition, and this constant thing is this exact thing that I have written over here. Does this make sense to all? Just type in yes if you got this expression. Others, did you get this, guys? Yes or no, or do you want me to repeat anything? Right? This is nothing. I told you before only. There is nothing to get scared of this expression, guys. I am telling it again. You can have this k anywhere in between I to j, right? And when you pick a particular value of k, this is what I was writing, and here mathematically I am writing this. So what is the problem in understanding? You know the result of this will have as many rows as ith matrix, as many columns as kth matrix, and now the number of rows in this, so even if you write mk plus 1 dot r instead of this, it will make the same sense, because number of rows in the k plus 1th matrix is same as number of columns in kth matrix. Okay, so I can directly say that the result of this will be of this dimension. The result of this will have this dimension as number of rows and this dimension as number of columns. So this is the constant cost. Asking it for the last time. Is that clear to everyone now? Does this expression make sense to everyone? I hope it should. Okay. Now this thing has to be computed for different values of k. Can you tell me from where to where the k should lie? I cannot do it just for k equals to I or just for k equals to j minus 1. I need to do it from k equals to I till k equals to j minus 1. Does that inequality that I have written make sense? Yes or no? Guys, does that make sense? Right? Okay. Now let us write the code for this. Okay. So let us all look at the board. So yeah, what was the physical interpretation of this? If I consider mi, mi plus 1, mi plus 2, mi plus 3, mj minus 1 till mj, then what is the minimum cost of multiplying them? So how should my dp matrix look like? Let's say this is my answer dp matrix. I am initializing everything to null. How should my dimensions look like? If the number of matrices were n, what should be the dimension of my answer matrix? Can someone quickly respond? It should be n cross n, right? Because guys, is there a problem here? Or because I think I have spoken this quite a lot times before, right? Right? Your first dimension should be matrix number and second dimension should also be matrix number, and matrix number can vary from 0 to n minus 1. So there are n choices for first dimension and n choices for second dimension also. Asking it again, does that make sense? Okay, I hope that should do because it's trivial. Okay, it should be n cross n. Now let's say I am trying to multiply. Okay, I comma j. Yeah, what will be my termination condition? In my recursion, whenever I see that I and j are equal, I can simply. Can someone tell me what should be done here? I should return 0. Very good. Because cost of multiplying a single matrix is 0, right? Otherwise, what I should do? There is no other termination condition. Otherwise, I should check whether I have solved this problem before or not. So else if I see that answer of ij is not equals to null, that means I have solved this problem. So I'll return answer of ij. Otherwise, it means now I have to solve it. So now when I have to solve it, unlike the last question of LCS or LPS, I don't just have 2 calls. I have multiple calls. I have n minus 1 calls. Do you realize this thing? Do you realize this thing that there are n minus 1 calls? So what did we do in recursion problems when we had to make multiple calls? Very good. We used to loop through it. Yeah. So I need a for loop over here, and in every iteration of the loop I need to pick the minimum so far. I need to pick the minimum so far because min of all these will be my answer, right? So that is the last expression that I want to write, that whatever will be the min of all these values where my k varies from I to j, that would be my answer, right? So what I can do is I can initialize my answer ij to a very small value of minus infinity, which is int underscore to a very high value of infinity, okay, because I am interested in minimum value, so I would initialize it to infinity. And then my k would vary from, as I said, I to j minus 1, okay. And then every time what I am going to do is I am going to first call the function for the part from I to k, so it will be mult I to k plus mult k plus 1 to j and plus the constant cost. That constant cost will be mi dot r into mk dot c into mj dot c. Does this expression make sense to everyone, what I have written? Does this make sense? Yes or no? Right? And now whatever will be the value of this, if that value is smaller than the current value of answer ij, then I would update answer ij. So my answer ij will always be minimum of this. So whatever is the minimum of this, that will go here. And then finally here I will return that answer ij. So here I am solving by iterating on all these values of k, all the different styles of split, figuring out the overall minimum, storing it here and then returning that over here. So to beginners this code looks scary, but once you write it, I would encourage everyone to complete this diagram. Can you all complete this diagram? Returning everything from bottom to top and then seeing how things are getting returned. Yeah, complete this diagram. In process of that you will see overlapping problems also. Okay, so there are many overlapping subproblems. So this way you will get a greater understanding of this, and then you will not fear from any variation of such kind of problem. How many of you completely got the code? Just type in yes, those of you who are perfectly clear with the code. What is the time complexity of this? That's an interesting question. Okay, so let us solve the time complexity together. Okay, how many distinct problems are there? What are the total number of distinct problems? Almost n square, yes or no? Almost n square, because your I varies from 0 to n minus 1 and j can also vary from there to there. So there are n square problems. And how much time do you take to solve one problem? In worst case, how much time do you take to solve one problem? Let's say your I was 0 and j was n minus 1. In that case, you would have performed almost order n iterations, yes or no? Yes or no? Yeah. So maximum number of iterations which would have run for any problem is order n. So if you multiply total number of problems multiplied by maximum time for any such problem, this would come out to be order of n cube. And so this is order n cube time complexity. How many of you got the time complexity really well? Just type in yes or no. Clear to all? Okay, I'll just keep this much for today. So I think that's it now. So guys, we have covered by far almost all the fundamental variations of DP. Okay, so now you guys should practice a lot. So there will be a homework, and that homework would contain the problems that we did today. I think we just did 3 or 4 problems today. I think 4 problems. So code them. And there will be some new problem also, try to code them also. And then now I expect you to be active. I want to see participation from your side. I want you guys to ask question on the WhatsApp group if you are stuck somewhere. If you do that, then only we'll be interested in answering that, and then you can on your own grow more on these topics. But first and foremost, code these questions, because these are utterly important. Okay. Once you code them, then you will almost see that any new problem that you see is either a variation of these or something which can be done because you just did this. Okay, so just have that thing in your mind. That's it for today, and I think you guys can go now. Can you guys figure out the bottom top approach for this? How many of you can figure out bottom top approach for this? Just type in yes. So I have been doing it for all the problems. I want you guys to do it on your own. How will the matrix be filled here? Will it be filled like LCS or will it be filled diagonally? Yes, very good. It will be filled diagonally. Okay. And what will be the value in every diagonal? Look at the termination condition. What will be the value in every diagonal? It will be 0, right? Very good. So now you can try it out. Now the moment you pick a cell, you have got multiple choices, and if you are filling diagonally, then only you can take those choices up. So please do that exercise. That is essential exercise. That gives you that that amazing feeling that, oh, this is how things are getting done, and that boosts your confidence. Cool, just this much, and see you all in the next class, and bye for today. Solve the problems. Okay.